Hey guys, we're going to be going over some networking stuff today that we're working on, and how we lay out these access switches. So be sure to stick to the end. We're going to kind of show you how it's done as far as laying them out and how we get these other switches going in tandem and everything else. So anyway, stick around. Please click on the like, subscribe, comment buttons down below, and we'll get started as soon as we roll the intro. Hey guys, so I'm headed out to the place we're going to go to do some access switch refreshes, and I'll do a little bit of explaining how sometimes these networks for different companies are laid out. But in this particular one, it's called a 3-tier hierarchy. So you have these core switches that go out to all the different areas of the campus, and each one has its own main distribution switch, which is a little bit bigger switch. And then that one goes to each section or floor of the department. Sometimes the floor has 2 different network closets, and each one of those have what's known as access switches. So what we're doing right now, we've replaced the core and the distribution switches, and now we're replacing the access switches. Of course, we always start with the basics: coffee. First, we got to get there. I've also worked for internet service providers and stuff, and on those, a lot of the time, they have more what's called a spine and leaf architecture, where, because now you're going router to router and you're going city to city and all these different networks, and when they do that, usually they have a redundant one, 2 links that aren't necessarily connected to each other, but it's 2 paths going to each one. What we're dealing with, though, is a 3-tier hierarchy of a core, distribution, and access switches. So guys, if you are a network engineer, an IT director, or somebody that's going to be laying out network closets and doing stuff like that, you want to look at things. You want to try to look into the future, hope for the best, but plan for the worst. Let's say it's 2 o'clock in the morning, you got a 24/7 business running, or even if it happens during the day, all of a sudden a switch goes down, okay? It throws an alert. It may take us 10 minutes or so to have that alert end up generating a ticket. And then we get it. We have to jump in, try to remote into the switch and do that. So, that may take us 5-10 minutes to get to where we realize something's down over there by looking on the core, trying to remote into that switch, not being able to. Well, then from wherever we're at, we may have a 20-30 minute drive at least, especially in DFW area, to get out to where you're at. Then once we get to the switch, if we try power cycling the switch and it doesn't come back on, and it's actually a dead switch that we've got to replace, now you've got whatever your workload is. So an example of this on this refresh, you'll see this is one of those that wanted his way and it's the only way to do it and it's right, and it's like, it's not the right way, number one. Like you'll notice in these videos, you'll see they butted every one of these switches up. He used these little short, 4-inch, 5-inch cables, 6-inch, whatever they are. And he set this rack up where it's going patch panel switch, because it's pretty and he can go on there. But what he's not thinking about, normally, the right standard is when you're doing that, on these racks of switches, you'll notice there's several columns that you can mount stuff in. The way we do on our standard is, say in the middle column, you have patch panels and stuff going, that things from the end users go to plug into, and each one of those are wired to their port in there. So you'll have your patch panels here, a longer cable, and then in this one you'll have your switches. And when we do it, we have a cable organizer, then we skip, it's called a U, but it's the same space that a switch would go in. And then, you know, we have the switch, then we skip a space, do the next cable organizer, skip a space. That way, one, the switches have room for airflow getting around the switches. Two, that's why you have a cable organizer. Like, this guy doesn't want to see all the cables. Well, that's why you have a cable organizer. That's why they have doors. The switch closet still looks pretty. But when you got the longer cables, let's say you have an emergency happen and I get out there, when it comes to me replacing the switch, I can drop the right iOS on that switch. Most cases, my spare already has the tabs. Since I've got that space, I can slide that switch right in on top. I can pull the cables out of the way, slide that switch up there, fire it up, log in it, make sure it's got the right iOS on it, and I can go ahead and fire that thing off. Well, when you have it like this guy, now after that 30, 35, 40, 45 minutes, and I've gotten out there and I've realized I got to replace a switch. Now, because of the way he did it, I can't just do that. Now, you know, if there's an emergency happening, now I got to go through the time. I've got to pull all the cables out. I got to remove the cable manager. I can't just slide my switch in because he's got these short cables going just from the patch panel down to the switch. So now what I have to do is unscrew all those tabs on the side of it, go slide it in from the back, slide it forward out, and then I have to re-screw all those tabs back in. I mean, all that's time consuming, especially when you're by yourself on an on-call thing. So, you know, when you're laying them out, think about that, you know, because really the right way is going the cable organizer, leave a space, put the switch, you know, in the same amount of space. We use about it's called a U, but the space of a switch. So think about those things when you're laying it out, not just your own, well, I want them all butted up there and pretty and in this one little area. You know, it's like, dude, yeah, it may look pretty, but as far as functionality, the switch is still going to work no matter what you do, but it's just you're making everybody's life harder. It's not that much prettier. And when it comes to having to work on them in an efficient manner, it really sucks. So, food for thought. All right, so we have arrived. So these are the Cisco switches we'll be installing. We're replacing the 3850s, and these are the 9300s. We have some geese out here visiting us in the parking lot. We'll see what adventures the day brings. Oh. So you can see how this is the core. See how it has all the fiber uplinks? Each one of these fiber uplinks go to a different switch in an access switch closet. They call me the Cisco surgeon. Anyway, you can see all the pretty lights we deal with. And the bad thing about cleaning, you know, they're using short cables. It sucks when you have to replace the switches and upgrade them. A little bit more of a hassle. It looks cleaner, but anyway, sucks when you got to do this part of it. But anyway, it is what it is. Looks like this is me, IT. Let's go check it out. And of course, this is the back view of the switches. You can see how the cables all come into these patch panels and they plug in the front, go into the front of the switches. Back here we stack all these switches together to make one giant switch. So you can see what we like to do. We brought the switches in. These particular ones, they tend to butt these switches up together, so we had to take out the cable managers. We dropped the switch that was existing a little bit, and we put our new switch right up above it. So today when we're doing this change, we'll move one of the uplinks up to this one, and you know, when you do that, you have to take it out of the port channel, shut it down on the core side, move the uplink over. Once the port channels are removed from both sides, then you can do a no shut, turn the link back on, and then both switches will be live. At that point, We'll move one or two up there, test, make sure they're working. Then we'll move all the cables up to the new switch. After everything's been moved on the whole stack of switches, then we'll be good to move the second link over. At least have redundant links, which is what a port channel is. So once both links have been moved over, the other switch is up and going and everything, then we can remove the old switches, put the cable managers back in here, which will hide these back in. I'll show you a picture of what it looks like afterwards. So let's talk about port channels for a second. So when you're laying, what I have here is a diagram. This is showing the stack that's there. It's got a switch stack of 3 switches that's linking to the core. I'm going to add a new stack of switches. Now normally these new ones, after you've got them configured, will be just stacking right on top of these so that it's easy to move all your cables and everything over, and then you just remove these old ones from finish. But just so you can see the difference better, I kind of separated them. This is the new switch stack. This is the existing. In our case, this is the 3850s. We're going to replace it with these 9300s. You've configured the switches, you've dropped them on and everything. Now it's showtime and you're doing it. Anytime you're setting these up, eventually you want this new switch to have everything this old one had. So this one, the IP address is this. As you're switching these over, you never want to have these cables going to different switches with the same IP address. So for the change, you see this is in the 10.100.100.25, the IP address. We picked another IP address, probably in a management VLAN or something, but it's going to be 10.100.100, and we just picked .50. You're going to want to find an IP address, make sure nothing's on it, ping it, make sure it's one that can be used, and set it to that. Also, if you have ICE or TACAX, you do want to go in there and create the switch and everything in there to make sure this is going to be authenticated on your system. All that aside, you're the day of, you've done all your homework, so we're going to do the change now. I put the steps under what you're going to do. So the first thing you're going to do when you're doing this is you're going to log on to the core, go enable, configure terminal, and I always move the second link first. This is a 20 gigabit interface. We put SFPs, and these are like 10 gigabit, but the port interface itself is a 20 gig interface. So I'm going to start with this one. I'm going to go on the core. I'm going to log in on the core to this interface. So I've already logged in that interface. I'm just going to do the command shut, and then I'm going to put no channel group 10 mode active, because this is port channel 10. So I want to take this, I want to shut this port down, which makes that link dead. I take it out of that port channel, and I'm going to verify that that link light and everything goes out. Now I'm going to log into my new switch. I can't remote in, it's not online, so I'm going to use a console cable to plug into the switch. I'm going to open up a terminal, use a session on there, and I'm going to go enable config T on this new one, go interface 311 because it's third switch. I'm going to do a shut. I'm going to shut that port, then do no channel group 10 mode active, because since I configured it just like the switch, and then I'm going to do a no shut on that port. So now I can take this. If you look at my step 3, I'm going to verify this light is link light on the old switch is out. If that link light is out, I'm going to unplug this fiber. So I'm going to do this, unplug it from here. I'm going to move that fiber over to my port on the new switch, right? So once I've done that, I am going to go back onto my core. I'm probably still in the interface. If for some reason you logged out, you're going to have to do the enable config T. If you're still in that interface where you shut it down, now you're just going to run the command no shut on your core. That's going to make this a live interface. So now I'm going to go to my new switch and verify that that link light comes up. And it may take a couple of seconds or something, but Just kind of be watching that. It may take 5, 10, 15 seconds or something, but eventually that'll turn green. Once it's done that, you know it's good. Then I'm going to take an Ethernet cable, you know, from my laptop and just plug it in any of these ports in here. Verify that, you know, one, I get a connection, and two, that it's all working good and everything is, I can get to a web browser and all of that. If everything's good on it, I usually just leave my console cable in. You can test it at this point by unplugging your console cable and try to remote into it with this IP. And, you know, you can do the rest of it remotely if you want to. I usually just leave my console cable plugged in it. It's up to you. So at this point, everything is up. So now you got 2 live switches. Keep in mind that this one's stacked on top of here, this one on top of here. All these lines, these are just showing the stack cables, that these are stacked together. So now you have 2 live switches. So now take 1 or 2 of your cables, you know, 1 or 2 of your end user devices, and move them up to the new switch, you know, 2, 3, 4 of them or whatever, and just verify that they come on, they're working good and everything else. Maybe move one of your wireless access points, just make sure everything's working good. Once that's done, you're good to go. Next step, you just, you know, you've already done a change window. People know there's going to be downtimes. You just start moving everything over on all the switches. Get everything moved over. After everything is moved over, this switch has no stuff on it. Everything is on your new switch. Then we're going to go into the after the move. Everything's up. We verified everything's working. Leave it until you verify it in case for some reason you have to start moving things back down. But leave it up. Once you verified it, everything's good, smooth transition, good deal, man. Let's move into the after move. All right, so you moved all your devices over and everything. Everything is going to this switch. Now we need to worry about this link. So after the move, we're going to log into our core, and then we're going to go enable config T. We're going to go to this interface, TWE101. I want to do a word about this. Really, this step is kind of unnecessary. Since you've already got a trunk link and this is now a kind of dead switch, no devices are on it, you can just unplug it from here. You've already probably put that in the right port channel when you config the switches. So, I've seen people do it both ways. It works fine either way. You don't even have to worry about that. Just unplug this, plug it into this port, and it'll probably come up with all that on it. Cisco standard best practice is to shut this down, take it out of the port channel and move it over and then put it back in. But basically you can just move this, move it over to here. So now you verified the light was out on that. You have the right one. You unplugged it, plugged it into the new one. Now on the new switch here, you're going to log into interface TE111 that you just plugged that into. You're going to shut that port, do channel group 10 mode active, and then do a no shut. Keep in mind, if you do a show run interface TE111, it's probably already got that 10 mode active, and then you don't really have to do that. It's probably already up and going. Then you can just log back on the core, go back into that interface TE101, and you can just do a no shut. And then you can come over here, verify that link light comes on and that everything is working. Then you can go back to your new switch. Once this is in the port channel 10, then log into interface TE311. Remember over here, you took it out of that port channel to move your first link. So log in to this interface right here and do channel group 10 mode active. Then you can verify your ports are bundled with, and you can do it while you're in the interface. If you use the do command, you don't have to exit all the way out. Just do show ether channel summary. And if they're both bundled in there, they'll both have a P. It'll show both links, TE 111 and 311, and it'll tell you the name of the port channel, and it'll have a P by both of them, which means that they're bundled. Do the word exit enter. That puts you back into global configuration mode, and you want to have this named as the same IP address as this so it works with DNS and everything. So you're just going to do the command IP address 10.100.100.25. That'll rename it back to what this is. And then now the switch should be replaced in all your system. Now you should be able to unplug your console cable. Now you should be able to remote into this by name, by IP, or anything, just like the old switch was there. This one's dead. So now you can like unplug everything on this one and just remove all the old equipment and start prettying everything up. And of course, when everything's finished, these 9300s do look similar to the 3850, so this is what it looks like. Hey guys, thanks for watching. As always, we appreciate you guys tuning in, and please take a second, click on the like and subscribe to the channel. Please be sure to comment, share with your friends. Be sure to visit the site and check out some of the different playlists we have. We have them on RVing, we have them on guitar lessons, we have a lot of different stuff. So spend a little time kind of looking around, and be sure to check out the other links to some great videos, and we'll see you on the next video.